4b, commutative property. The commutative property says that you can change the order of the values being operated on, and the result of that operation will not change. So let's take a little look at that and see what we mean by that. If I say 3 plus 2, we know that that equals 5. 3 and 2 are the values. The operation is plus, or addition. So the commutative property says that addition is commutative if 2 plus 3 is equal to 5. So I changed the location of the values while keeping the same operation, and the result turns out the same. So therefore, addition is commutative. Addition is commutative. Well, what about subtraction? 6 minus 2 is equal to 4. 2 minus 6 is equal to negative 4. Okay? They're not the same, therefore subtraction is not commutative. What about multiplication? 2 times 5 is equal to 10. 5 times 2 is equal to 10. Multiplication is commutative. Let's try division. 4 divided by 2 is 2. 2 divided by 4 is 0.5. Division is not commutative. Let's try exponents. 2 cubed is equal to 2 times 2 times 2, or 8. 3 squared is equal to 3 times 3, or 9. Exponents are not commutative. Let's try radicals. The square root of 4, and remember that's the index of 2. The square root of 4 is equal to 2. The fourth root of 2, I'm just going to make that really simple and say it's not equal to 2. Because what number, if you take 4 of them and multiply together, do you get 2? It's going to be something a little over 1. So that is not equal to 2. So radicals, square roots, etc. are not commutative. So we have come up with the fact that addition is commutative, as is multiplication. So we usually refer to that as the commutative property of addition and the commutative property of multiplication. So if I have 17 times 21, and I want to use the commutative property to rewrite this, then I can go, oh, well, that's 21 times 17. If I have 4.6 plus 9.2, using the commutative property of addition, I can change that to 9.2 plus 4.6. So basically, this is a tool that's going to help us when we're having to deal with order of operations and we're dealing with multiple values, that we can move around the numbers for addition and for multiplication, and it will not affect the value that we get or the result that we get. Now, I find this very important because it allows me to do possibly some additions or some multiplications in a much simpler way, such as this. Now I have 13, 25, 27, and 8, and if we were going to add this, we just go 3 plus 5 is 8, plus 7 is 15, plus 8 is 23, carry the 2, 2 plus 1 is 3, plus 2 is 5, plus 2 is 7, we come out with 73, and that's our basic addition. But using the commutative property of addition, I can look at this and go, well, wait, 7 plus 3 is 10. Right, remember this was 3 plus 5 was 8, plus 7 was 15, plus 8 was 23. So I had to take these individual steps, and I was always dealing with numbers that weren't even. I mean, didn't look very pretty. Whereas 3 plus 7, I see that immediately, oh, that's 10. So I've already got 10, plus 5, 15, another number that I can work with easily, plus 8, 23. And then I may see, oh, 2 plus 2 plus 1, that's 5, plus 2 is 7, 73. So it may allow me to do my multiplication or my addition quicker, or even more in my head, not having to use a calculator as much, because I can group things together that match up as opposed to having to work in that set sequence. So that's commutative property of multiplication and commutative property of addition.